Accuracy, precision, and tolerance are three separate but closely related concepts that are often used to describe the manufacturing and measurement of finished parts. Accuracy describes how close the result is to an ideal or standard value. For example, if we plan to CNC machine a part that is 105 mm long, then accuracy refers to whether we can machine this part to the required size. The closer the part is to the standard size, the more accurate the part is. Precision is different from accuracy and focuses on repeatability. For example, even if we accidentally make a part that is very close to the target size, it does not mean that each manufacturing is with precision. If we can repeatedly produce the same size and quality parts over a period of time, then this is a manifestation of precision. In complex assembly processes, the tolerances of multiple parts will gradually accumulate, which is called tolerance stack-up. Imagine an assembly that requires multiple parts to be put together, and these parts have certain tolerances or deviations. When the tolerances of all parts are gradually added up, the final assembly result may deviate from the nominal value. This is why it is necessary to not only measure individual parts, but also pay attention to the tolerance control of the entire system. Many designers mistakenly believe that tight tolerances or high precision designs always result in better quality. In fact, overly tight tolerances not only make manufacturing more difficult, but also lead to higher costs, longer production cycles, and higher scrap rates. To streamline your development process and save money, keep the following tips in mind. When designing an assembly, focus on the overall function rather than the extreme accuracy of each individual part. As long as the assembly works well and reliably, you have successfully completed the task. Avoid requiring precision on all dimensions, which not only reduces costs, but also increases production efficiency. Avoid using tighter tolerances in your designs than are actually required. This will help you reduce manufacturing pressure and reduce production costs. With these methods, you can save time, money, and frustration in the development process on your next project. Focus on the performance of the overall system rather than just focusing on the accuracy of a single component. Until next time, don't forget to subscribe to our content and click the little bell to get updates.